Hi there and welcome. Today we're going to talk about on-torch extraction, which is increasingly common in welding. So, what does it do? It removes fume at the arc where it's produced, it protects the health of welders and bystanders because they don't breathe in the fume, and it's recommended by the HSE for large components that don't fit into an extracted booth or onto an extracted bench. In a nutshell, on-torch extraction is a way to control fume exposure, and this video covers some of the known issues and, more importantly, offers solutions. If the fume is not adequately controlled, exposed workers are at risk of ill health. Effects can range from eye, nose and throat irritation, metal fume fever, which is a flu-like illness, serious lung diseases including lung cancer and asthma, increased susceptibility to pneumonia, nervous system damage, amongst other effects. We really want to avoid breathing in the fumes. So, let's take a closer look. This is a MIG torch. Not only is it one of the most common types of welding, but it's probably best suited to on-torch extraction. The average MIG welder creates over 30 kilograms of fume a year. If this is not extracted from the workplace, where does it go? Who's breathing it in? As the name implies, the extraction is built into the torch itself. It works very simply. Fume is sucked into the shroud that sits just behind the nozzle. The fume is then drawn through the welding torch and down this flexible hose, which is typically either 4 or 5 meters long, through this interconnecting duct and then into the extraction unit. As you can imagine, it can be quite congested in here because inside you have a power cable, hose for shielding gas, conduit for filler wire, and in some cases, cooling water. There's not much room for air to pass, so these systems generally operate at high pressure. One of the great advantages is the extraction moves with the torch, so it's always in the right place. There's no extraction hood that needs to be repositioned, so control is not affected by the size of the workpiece. This is not always the case with other types of extraction. As these systems must overcome high resistances, selecting the correct extraction unit is critical. We can't just connect up any extraction unit or a vacuum cleaner and expect them to work because they're just not powerful enough. These are specific on-torch extraction units. They both contain a fan, which provides the suction, and filters, which scrub the air. These then return filtered air back to the workroom. This one has a handy dial that can adjust the flow, and this one has an inverter, which allows airflow to be preset and will automatically ramp up and down to maintain the airflow. This is interconnecting ducting. It connects the extraction unit to the welding torch and is available in various lengths. These are typically 5 to 10 meters in length and help to position the extraction unit to the welding rig. First, I'm just going to put on some PPE. Let's have a look at the difference the extraction makes. We can start by looking at the fume levels if we weld without any extraction on. As we can see, there's significant fume released, which is very visible in the light of the arc. Let's try again with the extraction turned on. Before we start welding, we should check the airflow and shielding gas rate. These have a big effect on fume control and can be easily checked with airflow indicators like these, which we'll talk about later. So, let's try again. Easy to see the improvement, isn't it? Used properly in the right circumstances, it's a very effective control. We can see how little fume escaped. Some extraction units can start automatically as the arc is struck. This is one of the big benefits because it increases reliability and ease of use. However, there are some essential tips to get the best out of these systems. Fume capture is sensitive to seemingly small and subtle changes. Often, it's not just a case of plugging in and expecting the best. Firstly, the torch angle is really important. The more upright, the better, because hot fume will naturally rise to the extraction. Research has shown that over 90% of fume can be captured, but as angle drops, so does the capture efficiency and more fume can be created. Whilst on-torch extraction lends itself well to both the flat and fillet position, it can also be used in the uphand position, though capture of rising fume may be less. Often, we might need to carry out some trials because there are a number of tools at the welder's disposal that have to be optimised. Some torches have slides and others retractable shrouds. These can be adjusted to regulate the airflow. So why do we need to do this? This is for welding in tight corners and where there is narrow access. This reduces the chance of stripping shield gas and avoiding the dreaded porosity. These tools to reduce airflow should only be used in these circumstances. Otherwise, fume control will be affected. It's important that welders, and let's be honest, that most welders are creatures of habit, receive some training when trying on-torch extraction for the first time. This is because on-torch extraction usually requires subtle changes in working practices to get the best fume control. The extraction rate is also really important as it should be matched to the process. Too little means poor control and too much will strip off shielding gases. This can result in weld defects which often have to be ground out. I mentioned airflow indicators earlier. Torches should be supplied with these. They're an easy way for a welder to check the airflow is right. If this float is in the red, then there's not enough airflow. We need to adjust it until it sits in the green. This may require adjustment of the airflow dial or maintenance of the equipment itself. These air inlets are prone to clogging, which reduces airflow and fume control. Spatter build-up is one of the biggest culprits, which even with the best will in the world is still likely to occur. Best not using too much of this anti-spatter though, because it also tends to clog up the extraction. The best solution is using a ceramic spray applied directly to the nozzle and extraction shroud. Quick tip, make sure the extraction's turned off, otherwise it will be sucked up and it can blind the filters. We need to talk about shielding gas. Manufacturers offer recommended flow rates and these can vary between environments, extraction rate, from torch to torch. If the shielding gas flow rate is set too high, understandably to protect against porosity, then the gas will just blow the fume away. Too low, then the extraction will strip the shielding gas. Not great. Gas flow can be checked by using one of these pea shooter style indicators. It's also helpful to know that with an on-torch system, we normally need to increase shielding gas flow slightly. There's a belief that all torches are the same. This is wrong. Just like there are different spanners for different sized bolts, torches vary too, and they need to be matched to the welding process. These variations include the gun size, the weight, the suction, the power, and so on. Depending on the type of joint we're trying to weld, we may require different front-end spares. I'm talking about the tips, gas nozzles, and extraction shrouds. The reason for this is to try and achieve a satisfactory weld whilst maintaining an optimum airflow at the arc. As already mentioned, too much suction will strip off the shielding gases, and too little won't capture the fume. Historically, on-torch extraction has had a bad reputation. Torches were cumbersome and heavy. Recently, they've become far more user-friendly, much lighter, more robust, and easier to handle. Reclassification of welding fume as a carcinogen supercharged the market, and manufacturers responded by upping their game. Between these two air-cooled torches, there is little weight difference. In most cases, the weight difference increase is only about 100 grams, about the weight of a chocolate bar. Water-cooled torches are naturally heavier, in part because they're carrying circulating water and the additional tubing. Extracted water-cooled torches are even heavier. The weight difference increase between these two torches is about 400 grams. That's about the same as a tin of beans. There are solutions, such as the use of a sheath magnet and potentially manual handling aids like a supporting gimbal. On the subject of flexible hose, maintenance is an important aspect. They often suffer from spatter damage and being dragged over hot steel, which degrades hose integrity. The resulting holes bleed air, which reduces fume capture. To try and prevent this, some manufacturers offer a leather sheathing solution that protects the hose. It's not always going to be the perfect solution because there are some inherent limitations. Problems can arise quickly when the on-torch extraction is not best matched to the process. Some examples include off-gassing. The extraction only works where the torch is. If the weld pool continues to off-gas, then that fume won't be captured. Tack welding. The automatic function may not kick in for very short duration welds, meaning fume escapes. Upright welding. We will naturally receive a lower capture efficiency in this position due to the buoyancy of the hot fume. As you have seen, the torches are naturally larger. Therefore, where space is severely restricted, choosing the most suitable torch and front-end spares is paramount. In these cases, alternative extraction types such as positionable hoods, possibly affixed on magnetic clamps, booths, or even downfloor tables may be more suitable. Like all extraction systems, on-torch is prone to wear and tear. Filters get blocked. Ductwork splits and leaks air. The extraction shroud gets knocked and dented, restricting airflow. And all these will affect fume capture. So it's important to maintain the entire system in good working order and carry out a thorough examination and test every 14 months. We also need to mention something that is often overlooked, and that is the importance of workplace culture. As an employer, switching to on-torch extraction can be a significant change. There may be a need to bring your welders along with you because people tend to resist change unless they see the benefits. It often helps to include the welders in the assessment and decision-making process at an early stage. Explain why you are planning to make the change. Do the welders know that welding fume is a carcinogen? Often, moving to on-torch can require testing different systems, so involving the welders in trials and then listening to their views on torch weight, balance, grip, ease of use and so on is a simple but very powerful action. Work closely with them to quickly address any concerns so the change is seen as a positive one rather than feeling enforced. Keeping the systems well maintained and having replacement parts available to fix any breakdowns or damage quickly will help maintain user engagement. Oh, and a bit of senior leadership interest and involvement is helpful too. We need to remember that even the best extraction system may not control all fugitive fume emissions. We may also need to use a suitable respirator and ensure good general ventilation too. A strong indication of effectiveness is to simply observe fume release. Obviously, take precautions for arc eye and don't stare at the arc, but fume escape or hanging fume clouds is an obvious indicator that the extraction just isn't working properly. Fume control is sensitive to what can seem small changes. So it is really important we receive some training when trying on-torch extraction for the first time. Most reputable suppliers will be able to advise on this. Please remember that it's important to maintain the extraction and that on-torch is just one control solution. Other extraction options may be more suitable. In summary, on-torch extraction is an excellent and versatile welding fume control solution, well worth considering if you're looking to protect yourself and others. I hope this has been useful. Thank you for watching.